Okay, in this video, I'm going to talk about another kind of confidence interval. It's when you have an unknown population standard deviation. In other words, the standard deviation you have is S, the sample standard deviation. When you have S, then you will use what's called the t distribution to construct your confidence interval. So if you have sigma, use Z. If you have S, use T. Okay, so the things you have to work this problem are you have to have a simple random sample, a sample standard deviation, that's S, and you have to have a large enough sample size. And that's still using the rule we've had in the other videos where if you have skew, you need at least 15. If you have outliers, you need at least 40. And if you have extreme values, you need at least 100. So again, if you have a population standard deviation, you will use Z's. That's what we did in the previous video. And if you have a sample standard deviation, you will use the t distribution and correct for degrees of freedom, which for now, the degrees of freedom will just equal n minus 1. So if you have a sample size of 20, the degrees of freedom would be 19. Okay, so here's a sample. We have a simple random sample of 50 movies with a sample mean of 118 and a sample standard deviation of 14. So we're talking about a problem with means, and we have a sample standard deviation. So we're going to use the t and correct for degrees of freedom, n minus 1. And we're going to construct a 95% confidence interval. So just running that all out of there. The information from that problem, n was 50, so degrees of freedom will be 49. That's just 50 minus 1. The sample mean is 118, and the sample standard deviation is 14. The 95% confidence interval, you'll have a critical value, a t value, equal to 2.01. So if you have the t table, just pull that out, go into the column that says 95% confidence, and go down to 49 degrees of freedom, and you should see at the intersection there 2.010. Okay, again, there's just a repeat of the information at the top. Now we have our confidence interval formula. It's always the statistic plus or minus the confidence coefficient times standard error. So our statistic is x bar plus or minus a t value, that's the confidence coefficient, times the standard error, which is s divided by the square root of n. So from there, you just plug in the values and solve. And as far as doing the calculations, that's it. If you need to, pause for a second. I'm going to say a couple of other things, but make sure you can get the calculations first. Okay, so I want to talk about some stuff that could come up in a multiple choice question. For example, it might ask you, or a multiple choice question might ask you to identify the standard error. In this case, that's Sx bar, and it's equal to S divided by the square root of n, or 14 divided by the square root of 50. In other words, it's just this last term of the confidence interval formula. On the other hand, if a problem asks you for margin of error, then it's equal to all of this stuff on here, the t times s divided by the square root of n. This is the sample statistic x bar plus or minus a random error. A margin of error. And so it's just going to equal t times s divided by the square root of n, which is 2.010, times 14 divided by the square root of 50. So we had standard error was just S over square root of n, and the margin of error, go ahead and multiply that by the appropriate t-value. And could also ask you about the width of the interval. And that's just the whole width of the interval. And if we had an interval that went from 114 to 1.02 to 121.98, it would just be 121.98 minus 114.02. And you can do the math on your own there. So just be careful when you're reading the multiple choice questions when it asks you for standard error, margin of error, or width, that you get the right ones. And that'll be it for this video.